All right, so the first thing I'd like to recommend people do before they attack problems is be aware of some of the formulas that are available, and you will need to know rather quickly as you take this test. First thing I want to say is it's going to be very important for you to try to commit these to memory, and I'll give you pointers on what you can do to memorize these formulas. But the test won't allot you time to wonder, okay, what formula was that? Okay, now how am I going? Is it pi r squared? Is it 2 pi r? The test won't give you that kind of time. So it's important for us to start where I'm starting, to try to give you some strategies as to how to commit these formulas to memory. So let's do that. It's not too many of them. We'll try to do the best we can. All right, so base times height, that's a common one. You'd have to know that. You'd have to know that the area, which is the space inside, let's write that down, space inside of an object, for rectangles, base times height. I'd like you to be able to notice that a triangle, if you cut a rectangle straight through the diagonal, you end up with a triangle, which the formula for the area of a triangle is half of what a rectangle is. So though you have to memorize two different equations, I want you to be able to see that if you memorize a rectangle, the triangle is not too far from that. So it's easy to commit to memory both. I'm also showing you that's two types of, really more than that, but here are two types of triangles that you'll be presented with. And I'm trying to show you that the height is always perpendicular to the base. Height forms that L shape with the base. This we call a hypotenuse. We'll talk about that later. Space inside of a circle, given by the formula pi r squared. Notice how half of a circle, formula for a semicircle, half circle, is half of the whole. That makes sense. So really you're only committing a little bit to memory. Just really basically two equations to memory. All right, because the others come from the initial. The perimeter, which is distance around an object. This is distance inside of an object. This is distance around an object. Formula for distance around an object is, let's call this the base, let's call it the height. Let's call that the base, let's call that the height. Two bases plus two heights. Base plus base plus height. Two bases plus two heights. I'd like that to make sense. If it makes sense, you don't have to memorize it. Here, the perimeter, or the distance around the triangle, is the lowercase height, which is the height of the shape. Uppercase height, or excuse me, I didn't mean to say height, hypotenuse plus the base, distance around. And then one way you can get that uppercase height is called the Pythagorean theorem. We'll talk about that later as well. But one way you can get this height, you can get one leg of a triangle given two, using this Pythagorean theorem. The circumference or perimeter of a circle, that's 2 pi r. The perimeter of a circle, distance around a circle, is 2 pi times r. We define r as the distance from the center to the edge of the circle. There are an infinite number of radiuses of the circle from the center to the edge of the circle. From the center to the edge of the circle, we call those radiuses. The distance around a whole circle is 2 pi times whatever the radius is. Then, last thing I really want to talk about right now is the volume. Notice I have the volume, same equation all the way through. I'll try to make that as easy as possible for you. We're going to do the same formula all the way through. Capital B means the area of the base. Area of the base. So I probably spent too much time talking about those formulas, but they are very important. They are very important. They're the backbone of solving all of these geometry problems that we're going to go through tonight. Call in 312-738-1060. I'll have these formulas handy, and let's just jump into it. All right, so the first problem, if you can't see it very well, I'll read it. If you can't see it very well, I'll read it. All right, so what it says is, yeah, you probably can't see this, but I'll read it. it says how many feet of weather stripping is needed to frame 2 windows with the dimensions indicated. All right, so you got to read these problems. You know that weather stripping typically goes around a window. Weather stripping goes typically around a window. So you'd have to read that problem, have it make sense to you, understand that this is not a problem where you're going to weather strip the inside of the window and know what kind of problem you're talking about. That is the perimeter. That's a perimeter problem, a distance around problem for 2 different shapes. So what I recommend you do here is refer to the perimeter formula for a rectangle, and then you go to this. But see, that all that would have to be in your head. You're not going to have time to wonder which formula to go to. So we've got window 1, which is the window on the left. We got window 2, which is the window on the right. The formula for a window is base times height. Or forgive me, we're working with perimeter. I apologize for that. So the perimeter is 2 bases plus 2 heights, and we're going to add that to the perimeter of the other window. The formula is 2 bases plus 2 heights. All right, so we get 2 times the base of this. I don't know if you can see it. It says 36 plus 2 times the height. I'm hoping you can see that. That says 54. All right, so that's the distance around one window. And then the other window, the base is 60. I don't know if you can see that, but it's 60 plus 2 times the height, which is 48. 48. So here you get 72 plus 108. That's going to be added to 120 plus 96. All that added together, you get a perimeter of, I did it ahead of time, 396, and the units will be inches. All right, so what I want to do is I just want to go through as many problems as we can. Let's look at another problem. This problem is number 2. I'll read it in case it's too small for you. All right, so what it says is a fantastic food company is redesigning its Bran Flakes box as shown. Find the capacity of the new box in cubic units. Cubic units, as you do a little bit of studying, it says cubic inches. Cubic inches is a volume. It's a unit of volume. All right, so the company's redesigning the box. I should have done a better job of defining. I define area, space inside. I should have said a flat surface or a 2-dimensional surface, a flat surface. Okay, a flat surface, and volume is the space inside of a 3-dimensional surface. 3D surfaces. All right, having some challenges spelling here. I'll just abbreviate. 3-dimensional surfaces, or 3-dimensional objects, let's say. I think that'd be better. 3-dimensional objects. All right, so volume is also space inside. All right, notice what they're looking for. They want to know that capacity, another word for capacity, is space inside of a box. It's 3D. That's what's telling you need to go to the volume. You're going to have to read the problems carefully and know which formulas to go to. All right, so the volume, we said, formula for the volume is the area of the base times the height of the object. So what you're going to do is you're going to go, the area of the bottom of this shape here is a rectangle. So the formula for the area of a rectangle is 8 times, the base times height is 2.5. 2.5. All right, so that's 8 times 2.5 times the overall height of the object, which is 11.5. All right, so you get the volume is equal to 8. Another way to write 2.5 is 5 halves. All right, times another way to write 11 halves is 23 halves. All right, so you can cross cancel here. You end up with 1, 4, so you get 20. The volume is 20 times 23 halves. All right, you can also cross cancel here. It becomes a 1, it becomes a 10, and you end up with 230. And the units would be cubic inches. Cubic inches, final answer. All right. Uh-oh, you can't see that. Sorry about that. Final answer, 230. All right, so if you have any questions on this, call in. The number is 312-738-1060. Today's topic is we're doing GED, really just geometry problems. It really doesn't matter for what test it is, but I got this from the GED book. By the way, for any of my students who might be wondering what page this is on, these problems are on page 919. That's 919. All right, let's keep going. We got more and more problems to do. Let's look at number 3 on page 919 of the GED book that we're working from. All right, so this is another problem. Fantastic Food, same company, is redesigning the soup can, different can. Which of the following may be used to find the capacity of the soup can? So you got to read that problem, underline keywords, capacity. Another word for capacity is space inside. How much space is inside this can? Well, the formula for the volume, we told you, was the same. All right, so the volume is equal to the area of the base times the height. So you ask yourself, what is the shape of the bottom of this shape? I want you to be able to see it's a circle. So you got to find the area of the circle. We showed you all your formulas. Formula for the area of a circle is pi r squared. So you put in the formula, pi r squared, all right, times the height of the object. All right, so I told you that the definition for a radius was from the center to the edge of the shape. We talked about that earlier in the show. So you have pi, right? You got pi, and the radius is half of 3 over 2. So you got pi times radius. You have to square that, times the overall height of the object, which is 4. Notice how, I'm hoping that you can see this, notice how they don't really want a final answer. They just want you to put it in a form right before you would put it in the calculator. So you'd end up with pi, which is 3.14. You get 1.5 squared times 4, and you'd acknowledge that that would be, looks like number 1. All right, so all these are problems that you would find on the GED test or even an ACT test or something like that.